Hi again, my name is Jonathan Lambert, and this presentation is going to deal with the formula for descriptive statistics. The formula is for the mean, the variance and the standard deviation, but this time when the data is represented through a frequency distribution. So we have our formulas for descriptive statistics. Once again, we want to differentiate between whether the data was taken from a population, or whether the data was drawn from a sample, as a sample of the population, in which case we have three separate formulas for the population, the sample, and the sample. The first formula we're interested in is the mean. The second formula we're interested in is the variance, and the third formula we're interested in is the standard deviation, standard dev. Okay. And let's keep in mind that we're dealing with a frequency distribution, so we're always dealing with a frequency distribution. The data has been presented through a frequency distribution. Okay, so the mean of a population when presented through a frequency distribution, well, the symbol for the mean of a population is mu. It's simply equal to the sum of the product of each x value times its frequency. So it's the sum of each x value times its frequency divided by how many values there is in the data set. In the sample case, x bar, which represents the mean, is once again it's equal to the sum of each x value times the frequency divided by how many values there is in the sample, small n. In the variance case, sigma squared is equal to, it's the sum of the difference between each x value and the mean times the frequency. It's the sum of the difference between each x value and the mean squared times the frequency divided by how many values there is in the data set. For the sample, we're talking the variance, s squared, is equal to the sum of the difference between each x value and this time the sample mean, x bar squared, times the frequency divided by small n minus 1, where we're reducing by 1 to make this statistic an unbiased estimate of the population variance. In the standard deviation case, well, by definition the standard deviation is simply the square root of the variance, so sigma is equal to the sum of each x value minus mu squared times f divided by capital N, the size of the population, and it's the square root of that value. In the sample case, s, which represents the sample standard deviation, is equal to the sum of each x value minus the sample mean squared times f divided by n minus 1, and it's the square root of that value. So, like in the case of the raw data set, we have three statistics for the population data and we have three statistics for the sample data. Because this data has been represented through a frequency distribution, the formulas all include f's that signify that the data represented has frequencies associated with it. Okay, and that concludes this presentation on the descriptive formula when presented with data through a frequency distribution. Okay, thank you.